Alright, so I just want to take a moment to show you what I mean about this, about how good the standard deviation is for describing the spread of different samples. So I'm going to give you two examples, and these are two data sets that both have the same median and the same mean, but they have quite different ranges, and you'll see that corresponds to quite different standard deviation values. So I've just made these up, so we've got 10, 20, 30, 40, 50, 60, 70, and we've got 34, 38, 36, 38, 40, 42, 44, 46. And so if you, so this is sample 1 and sample 2. Okay, so as an exercise, work out the variance and standard deviation of these, but I have done it on Excel, and so I know that sigma of sample 1 is equal to 21.6, whereas the standard deviation of sample 2 is only 4.3, which stands to reason because the spread here is much smaller. We're only going to, the range is much smaller, so it stands to reason that the average of the differences between the various measurements and the mean, so the mean is 40 in both cases, sorry. And in both we have, it looks like there's an even spread of measurements around that mean of 40. Anyway, so it stands to reason that the standard deviation of sample 2 is smaller than the sample of sample 3. Okay, now I'm just going to put these on, make kind of a graph, reminiscent of the box and whisker plot. So if we've got 40, 50, 60, 70, etc. So then if we've got sample 1, you've got the mean is here, and we're going to, and then the standard deviation spreads out there by 21, so that goes from like here to like here. So that's one standard deviation on either side. And so 68% of the values should be within that range. But then for sample 2, the mean is exactly the same, but one standard deviation on either side only looks like that. Okay, so this is the mean, which is identical in both cases. And yeah, why don't we go ahead and plot the individual values? So we've got, for sample 1, we've got 40. Whereas for sample 2, you've got 40. Okay, so they're much more clumped together. So that stands to reason. So that's, and the standard deviation is really handy because it has the same units as the original measurements.